Lesson C5, Intermediate Calculations, Topic 6, Logical Functions. The learning objectives for this topic are to understand the different logical functions, which are if equals, if tag exists, and threshold. So the if equals function is similar to an if then else type construct that you will be familiar with if you use various programming languages. Then we have if tag exists. This is an error prevention function that allows you to make a dashboard or a calculation with a tag that may be coming online soon but isn't there yet, but you don't want to have to keep going back in and editing the dashboard. And then threshold is used to return one value if a tag is below a certain value and another if it's above it. So it's a if above something, then return A, otherwise return B. So the constructs for the logical functions are as follows. The if equals function takes a tag, a comparison value, which can also be another tag, what to do or what to return if it's equal to the comparison, and what to return if it's not equal to. Now both of these can also be other tags. And then finally we have the precision. This allows us to have a level of tuning, so we can allow a bit of margin around the comparison, or we can set it to 0 if it needs to be an exact match. If tag exists takes two arguments. It takes the tag and then what to return if that tag doesn't exist. And again, this can be another time series. If the tag does exist, it will just return the value of the tag itself. And then finally we have threshold. So threshold takes a tag, the threshold to check, and this can also be another tag. And then we have what to return if it's greater than or equal to. Again, this could be another tag, and what to return if it's less than. So here I've made some examples of each of these functions using a simple sine wave as the basic tag, and I think this illustrates quite well the differences between them. So first of all, let's look at if equals. So with if equals, if we take a calculation like this, here we have the if equals, we're looking at a sine wave that will alternate between 0 and 1, and we're going to compare it to a constant value of 0.9, but like I mentioned, this could equally be a tag. And then I'm going to return 1 if the sine wave is equal to 0.9 and 0 if it's not. But I've also set a precision of 0.01, so I'll get a little bit either side of 0.9. And so here you can see against the sine wave, what this does is it gives me two spikes every time the value of the sine wave is 0.9. But there's nothing when it goes below. So we've converted a sine wave into two peaks at semi-regular intervals. Now if I expand the value of the precision, I can create this series above. So this green series, I've set the precision to be 0.5. And here we can see that what we've done is we've effectively chopped out the middle pieces of the sine wave, and we've made this quite interesting looking function here. And this is different. This is a significantly different outcome from the threshold. So it's worth just jumping to look across here at the threshold for now, because the threshold, I can just set a single value, and if it's greater than that value, I'll get my return value. So let's look at what I did in this orange series. So here I've got my threshold. I'm looking at the same sine wave, but I'm saying that let's take the threshold to be 0. So every time the value of the sine wave is above 0, then return the value 1, and if it's below, return 0. So I effectively convert my sine wave into a square wave, like this. Now the green series above, instead of returning 1, I return the value of the sine wave itself. So here we've got if it's above 0, then return the actual sine wave, otherwise 0. And it acts a little bit like a voltage rectifier, except that it's missing the low portion. So what I could have done, say, is if it's below 0, multiply it by -1 or something like that, and then I would have got a true rectification. But it means I've made this kind of interesting series that it's got a hop and then it just goes flat for a bit. But that's the difference between the two values. The if equals will catch it on the up and down, but you can miss out the middle, whereas the threshold, you can just completely cut values off. Okay, so finally let's look at the if tag exists. So the blue series here says, if the tag exists, it will return the tag, otherwise return the value 9. So I've put our sine wave in here to check, and of course we know that exists because we're calling the signal generator, and so the value that the function returns is the sine wave itself. But then in this orange series here, I've made up a tag number. I've made up a tag 23xyz1234.pv. I know that doesn't exist, and so the function is returning 9. But crucially, it's not throwing an error. So the use case for this is something like you're commissioning a platform and you're bringing online some meters. Then they're appearing in the system at some point in the future, but you don't know when, but you want to pre-configure your dashboard so that when they do exist, they start working. Now, so you may just set it to be 0 when the tag isn't available, or you might have an alternative meter that you would like to use while you wait for the other one. So say you might use the outlet from a test separator initially while the platform's been brought online, but when the physical meters come online, you want to switch to them. You know what the tag number is for it, but it's just not been built in the historian yet. You could enter that in your dashboard beforehand, and then as soon as the tag exists, that number will appear straight away. Particularly handy if it's coming on over a weekend and you don't have to want to have someone on call. So okay, that covers it for the logical functions.